Artificial intelligence seems to be an ambiguous force that has transformed the global economy. And while AI exists in cyberspace, it has also left a huge physical footprint in the real world. Welcome to the third season of our Lighthouse Project, exploring sustainable AI. In this video, we will discuss why we should care about sustainable AI and solutions for sustainable AI to ensure that AI benefits both society and the planet. Let's dive deeper. While the origins of AI date back more than 60 years to the mid-20th century, the explosion of generative AI products such as ChatGPT or Midjourney over the past 2 years has taken the popularity of the technology to new heights. However, this popularity has come at the cost of high energy costs, a reality that is often set aside and left unattended in today's operations. Alex is a PhD student at the Technical University of Amsterdam and founder of the digital sustainability blog. Alex analyzed the trend in AI energy use. He predicts that current AI technology could consume as much electricity as the entire country of Ireland, could say like 29 terawatt hours per year. Many generative AI tools rely on a natural language processing technique called large language model. While the training process for this large language model typically bears the burden of environmental consent, models can consume terabytes of data and use more than 1,000 megawatt hours of electricity. Alex reports emphasized that in some cases, the amount of power consumed in making inferences can be even higher. It could be stated that a single large language model interaction may consume as much power as leaving a low brightness LED bulb for an hour. The explosion in data centers demand is attracting the attention of all kinds of investors, growth capital, buyout, real estate, and increasingly infrastructure investors. As you can see from this chart, in the US market alone, data center demand measured by electricity consumption reflecting the number of servers that can be housed in a data center is projected to reach 35 gigawatt by 2030, up from just 70 gigawatts in 2022. According to Maxis analysis, the US accounts for about 40% of the global market. According to the International Energy Agency, global power demand for data centers and AI will double by 2026. Electricity demand for traditional data centers, dedicated AI data centers, and cryptocurrency is expected to rise dramatically. In 2022, traditional data centers dominate electricity consumption, but by 2026, the combined demand for cryptocurrencies and dedicated AI data center is expected to grow significantly. The sustainability plans of other large tech companies has also been challenged by the explosion of data centers. In an environmental sustainability report, Microsoft said that data center has led to a 29% increase in the company's emission from a 2020 baseline. Microsoft said that the company will use 6.5 million cubic meters of water in 2022, mostly for cloud data center. It is a 34% increase from the previous year, and is believed to be at least partly due to the generation of AI workloads. Microsoft reiterated this goal of becoming an aggressive water-saving company by 2030. As part of this effort, Microsoft says they have invested in 6 new projects that are expected to replenish more than 15 million cubic meters of water over the next decade. Investing in green technology is not just critical for the environment, it also offers significant economic opportunities. The use of renewable energy in data centers can help reduce carbon footprint while sustainability meeting growing energy demand. Data centers powered by renewable energy resources, such as solar or wind, can significantly reduce the environmental impact, and companies such as Robeco emphasize the strong growth potential for companies that provide energy, that is, efficient solution and infrastructure for data centers. By investing in green technologies, business can reap long-term economic benefits and weather potential economic downturns. Advanced cooling systems are critical to manage the heat generated by AI workloads. Technologies such as immersion cooling and AI or machine learning for optimized cooling help reduce energy consumption and environmental impact. For example, Google uses AI-powered and climate-conscious cooling system in these data centers that can reduce cooling energy consumption by 40%. Large tech companies are also focusing on sustainability. Microsoft's commitment to sustainable water use by 2030 includes significant investment in water replenishment programs. These efforts not only address environmental concerns, but also align with corporate sustainability goals and attract environmentally conscious investors and customers. Similarly, Amazon Web Services has invested in wind and solar farms to power its data centers, with the goal of achieving 100% renewable energy by 2025. The economic benefit of adopting sustainable practice go beyond directly cost saving. Companies that prioritize sustainability typically improve brand reputation, customer loyalty, and regulatory advantage. These factors contribute to competitive advantage in marketplace and long-term financial sustainability. For example, Facebook's data center in Sweden, which used hydroelectric power, it's considered one of the most energy-efficient data centers in the world, resulting in both cost saving and a positive corporate image. While AI has great potential for sustainable development, there are several challenges that need to be addressed to fully realize this benefit. One of the main challenges is the intermittency of the renewable energy resources, such as solar and wind. These sources of energy are not always available, which can lead to erratic power supply. To address this issue, companies are exploring 24/7 power purchase agreements that combine carbon-free supply and storage solutions. Google, for example, has implemented this agreement to ensure a continuous supply for renewable energy to this data center. The current infrastructure in many data centers is unable to effectively handle growing energy demand. Investing in advanced cooling systems and modular data center is critical. Like Microsoft is exploring the use of immersion cooling, which is submerged server in a special liquid that help dissipate heat more efficiently than traditional air cooling. Similarly, Facebook's data center in Sweden uses an innovative design that takes advantage of the cooler climate, reducing the need for additional cooling. Improving the efficiency of algorithms and data processes is another key area. By optimizing algorithms and improving data collection techniques, significant energy savings can be made without sacrificing AI performance. For example, OpenAI is working on more efficient training techniques to reduce the energy required to develop large models. In addition, DeepMind has developed AI algorithms to optimize energy use in data centers, reducing cooling energy consumption by 13%. As we continue to integrate AI into our daily lives, it is critical to invest in sustainable techniques and practice. By addressing this challenging and implementing effective solutions, we can ensure that AI benefits both society and the planet. Please join us for Lighthouse Project Season 3, focusing on sustainable AI, where we dive deeper into these critical topics and explore innovative solutions for sustainable future.